So today we'll discuss about the centrifugal pump. Okay. So centrifugal pump you have seen most of your houses. Okay. It's a common device nowadays where you impart a fluid from a lower head to a higher head. What does a turbine do? It takes the fluid from the higher head, and then because of okay. So it is exactly reverse of a turbine. So turbine takes the fluid from a higher head and transfers it to a lower head. Whatever the energy deficient is there, that would be transferred as the energy output. Now you are giving energy to the system to transfer it from a lower head to a higher head. So that is exactly pump and turbine are opposite to each other. So that you have to remember. So precisely, I can say a pump would be exactly reverse of the Francis turbine. Okay, if you observe the Francis turbine, even the pump will be same as the Francis turbine as well. But you would send the water from higher region so that the impeller rotates, and this impeller is connected to a generator in case of Francis turbine. But here it is exactly reverse. Okay, so different parts of centrifugal pump we can see. The main part, the main part is the suction pipe. This is a suction pipe, and next would be the delivery pipe. Okay, this is the water sump strainer. What is a strainer? In the sense it is a small filter where it helps the dirt not getting into the suction pipe. So that is known as strainer. Or what is a footwall? How many of you know what is footwall? Most of you have seen it in case of your centrifugal pumps at your homes. What do you mean by a footwall?
So yes, sir. So that type triangle cone shape will there.
Cone shape would be there, isn't it?
Used to
Why?
bleeding,
Why it is useful?
bleeding purpose
So
to
to
remove contents,
Yes.
to remove
For
air from
efficient
the
suction.
Okay.
bleeding
So
missing
what?
air.
Okay. So one thing I would say, whenever in order to centrifugal pump to operate, your whole of suction pipe should be filled with water. Not only suction pipe, the whole of suction pipe and the casing up to delivery flange must be filled with water. If it is not filled with water, then you cannot have an action of centrifugal pumping. So that is the basic fundamental criteria you must have. So if you don't have it, then what you have to do, there will be separate pipe attached. If there is some of the water missing, if the some of the water is missing, then the separate pipe would be added where you will add water, isn't it? And that particular process is known as priming. Hope this all things have been explained in the lab as well. Correct?
yes, sir.
So all these things are, so once the whole of suction pipe is filled up, then only you can have a centrifugal uh, pumping. That is what it is there. Now, since that I have told you, if there is no footwall, then if the pump stops its operation, okay, if I switch off the pump, what happens to the water which is in the casing and the suction pipe? It will get back to the sump. No, it will come back to the sump. So in order to avoid that, footwall will be there. So footwall, whenever there is no suction, it stops the water getting back to the sump. So only it will allow in this direction, it will not allow in this direction, water to flow in this direction. Understood the functioning of the footwall? Okay.
Yes, sir.
Okay. So that is very important thing. So you know the impeller induces a centrifugal force. Now I'll try to trace the water molecule, how it would emerge out from a centrifugal pump. So kindly observe this. So this is the water molecule here. Okay. So this particular water molecule, kindly observe this. It would go like this, pass the strainer and the footwall through the suction pipe. Kindly observe now. Okay. So first it will be at the eye of the impeller. Eye is the center of the impeller. From center of the impeller, it would be thrown outside because of centrifugal action from inlet to the outlet. Centrifugal force always acts from the center to the radius, isn't it? Outward the radius. So therefore, water would be thrown out of because of centrifugal action. Then it would be sent up because of energy. Understood? So that is how the movement of water molecule takes place. Now, while concerned with this, you have again a lot of efficiencies and a lot of heads as well. There was a head in case of a turbine, Pelton, Francis and Kepler. No, here also you'll be having many amount of heads. Okay, let us discuss what are the different amounts of heads that you have in case of centrifugal pump. So, from the eye of an impeller, from the center of an impeller to the foot valve, okay, that is known as the suction head. Understood? From an eye of an impeller to the delivery, that is known as delivery head, HD. Now, because this is a pipe, okay, I will tell you, see this beautiful concepts now. Because this is a pipe, suction pipe, as the water molecule is entering the suction pipe, whether there would be friction losses? Yes, because it is traveling within the pipe and there would be friction losses HF, where you will calculate using the equation 4FL V square divided by 2GD. Am I right? There will be friction losses since it is traveling in the pipe, no? Correct? Yes or no, man?
Yes,
Yes, sir.
Okay. So that particular friction losses, I would say as friction losses in the suction pipe. So this particular head is known as friction suction head. And similarly, because of the delivery pipe is also a pipe, you will be having a losses due to friction in delivery pipe as well. So this is the head loss due to friction in delivery pipe, and this is head loss due to friction in suction pipe. Understood? Now, plus at the outlet, this is the outlet of the this one pump, no? At the outlet, whether you require the velocity of the flow or just if the water falls is enough, you require some velocity, no? That is why you are pumping, correct? There will be some velocity against which it has to work on, and that particular velocity is known as V square 2G or discharge velocity head. Okay, so this particular known as discharge velocity head at the outlet. So if I have to design a pump, I have to design so that it takes care of suction head, delivery head, head loss due to friction at suction pipe, head loss due to friction at delivery pipe, and as well as the velocity head at the outlet. So it has to take care of all these 5 components, and the total head, that is the summation of all these 5 components, is known as the manometric head. So basically, manometric head is the head through which your pump would work. Okay, again, this forms an important question where different types of heads are being asked. Clear? Clear about this? Any doubts here? Any doubts?
no, sir.
Okay. So this is for the reference I have written in the reading. Let it be as such. Okay. Do not get confused. These are the typical examples, typical questions that were asked. Okay. typical questions that are asked. You can observe the manometric head, which are stated here. It is given as the suction head plus delivery head plus head loss due to friction at suction head, head loss due to friction at the delivery head, and even the final velocity head at the delivery pump. Okay, so you can observe the things. So this is very, very important. Different types of heads is very, very important. Okay. Next is the efficiencies. Okay. So again, manometric efficiency or hydraulic efficiency, if I talk about manometric efficiency, is nothing but the hydraulic efficiency. It is the ratio of manometric head divided by head imparted by the impeller to the water. So what is that actual manometric head divided by the head imparted by the water is U2 VU2. So head imparted by the water is V2 VU2 against the manometric head. The ratio of these two is the manometric or hydraulic efficiency. Second one is mechanical efficiency. This is simple to be understood. So efficiency mechanical is power generated by the impeller. So power by impeller divided by, so power what you are giving at the pump shaft. So I can say it as power input or the shaft power. Power input or shaft power. So this is the mechanical efficiency. Volumetric efficiency, you already know it as actual discharge divided by theoretical discharge. What is the actual content of water which is coming out? And according to theoretical aspects, according to your calculations, what was the amount of water you expected and how much actually it has been resulted? That difference is known as the volumetric efficiency. Overall efficiency, if I say, total output by total input. Input you are giving as shaft power, output you are getting it as manometric head. So the ratio of manometric head divided by the shaft power is known as overall efficiency. Remember, overall efficiency will always be the product of manometric efficiency and the mechanical efficiency. So all these concepts are again important for your examination. So I would mark this as important. Okay, not this one, man. Overall efficiency I'm talking about. So the last concept we are trying to deal in case of pumps is regarding slip and cavitation. So this forms an again important aspect. So what do you mean by a slip? Anyone would know? Anyone knows about this? What do you mean by slip? What do you mean by slip? Okay, no problem. So what is, there would be some head which is known as Euler head. Okay, so Euler head is the actual head or the theoretical head based on the theoretical calculation that you are going to expect at the outlet of the pump. So Euler head is the actual head that you are going to expect at the outlet of the pump because of various reasons, like because of some leakages in case of a centrifugal pump, because of some vacuum being created in the suction pipe, because of the cavitation, because of inefficient mechanical transformation, various reasons I would say. What happens, whatever head you actually get at the outlet will not be equal to the Euler's head. Euler's head is what? It is the highest head what you get at the outlet of a pump. So for the highest head, you will never get the highest head, rather you would get a little bit smaller head because of the various losses whatever I have mentioned. So because of the losses, there is a difference between the actual head and the Euler's head, and that is known as the difference between these two heads is known as slip, and the ratio between these two heads, actual heads and the Euler's head, is known as the slip coefficient, which is given as mu. So actually it slips from the maximum value, that is why it is known as slip in case of a centrifugal pump. The slip, you just remember as a difference between the Euler's head and the actual head. Okay, now coming to the cavitation. So if you want to understand the cavitation, you have to go into the centrifugal pump. So this is a centrifugal pump and this is a suction pipe, whatever is that. Okay, since the suction pipe will be under the suction, it would be under the vacuum. Okay, so here the pressure would be lesser than the atmosphere. That is why the water gets inside the suction pipe. Okay, now there is something known as the vapor pressure of water. There is something known as vapor pressure of water. If the pressure at the suction pipe is lesser than the vapor pressure, what happens, you know? The water automatically get transforms into vapor. So if water get transforms into vapor, okay, what happens? What is the problem in that is, so this particular air bubbles which are formed within the suction pipe will hit the blades of a pump. So if they hit the blades of a pump, what they will do, they would damage and create a cavity on the blades of a pump. So this particular problem of creating cavity on the blades of a pump because of air bubbles created in the suction pipe when the pressure in the suction pipe drops below the vapor pressure, this is known as cavitation. Cavitation is because creation of cavity because of the air bubbles. How are air bubbles formed? When the vapor pressure, when the pressure inside the suction pipe drops below the vapor pressure, air bubbles are formed, and these air bubbles will strike the blade so that it creates a cavity, and this particular phenomenon is known as the cavitation. So any other doubts here?
Sir, we can write in our own notes, no, sir, like you explained.
Yeah,
We can write in our own notes, no, sir.
you can write it, but it has to convey the same content. That is all is required. Okay. So what are the precautionary measures that you can take in order to avoid cavitation? You have listed here: lower the temperature of water, do not use the high temperature water, do not pump the high heated water, always go with the low temperature water so that the cavitation does not occur. Ensure suitable liquid level in the suction side. That if there is no liquid, cavitation, air bubbles may occur inside the suction pipe. So always ensure there is a good amount of liquid available in the suction pipe. Okay, by suitable impeller design also. So by taking care of suitable impeller design, so if the air bubbles are formed also, you have to design an impeller so that it would squeeze out of the blade. If it would squeeze out of the blade without creating a cavity onto an impeller. So suitable impeller design also could help. And the net positive suction head which is available always should be higher than the vapor pressure of the liquid. So that thing you have to take care. Okay, checking the clogged filters, strainers, and blockages in pipe. What happens if the strainer, there will be a strainer at below the footwall? You know, you have to always check the strainer. If it is clogged, what happens? More air pressure is drawn. If air pressure is increased, again it will be greater than the vapor pressure, so that the air bubbles may be created and cause cavitation. So always check for the strainer and clean it regularly so that cavitation does not occur. So this is all about this one. The portions what? The third internal. So after the third internals, we will try to discuss the problems. Okay. Even